Assalamualaikum warahmatullahi taala wabarakatuh. I am Muhammad Faisal bin Narjili from Faculty of Science and Technology, University Science Islam Malaysia. Today, I'm going to present my work on the study of 3D printed polyurethane acrylate gel polymer electrolyte via stereolithography method. First, 3D printing or additive manufacturing is a process of making three-dimensional solid objects from a digital file. The creation of a 3D printed object is achieved using additive processes. In an additive process, an object is created by laying down successive layers of materials until the object is created. Each of these layers can be seen as a thinly sliced cross-section of the object. 3D printing can cope with highly complex and detailed structure preparation that are difficult to achieve with conventional methods such as casting and machining, simplifying the fabrication process. There are many categories in 3D printing which are currently available. For example, wet polymerization, material jetting, and the most famous one, material extrusion. In my work, I use wet polymerization (SLA) as the method to fabricate my polymer electrolyte, as it can produce high resolution and precise geometry. How SLA works is first, the laser light from the light source will be focused to the vat that consists photopolymer for a few seconds for the first layer. After the first layer cured and hardened, the stage will move up and allow the second layer to be printed. The step will be repeated until the final object completed as preset from the computer-aided design file. Next, gel polymer electrolyte typically made by adding a small amount of liquid plasticizer and or solvent to a polymer salt combination. The polymer matrix jobs is to maintain a solid state matrix that facilitate ion migration in solvents, allowing a conductivity value up to 10 power negative 3 Siemens per cm at room temperature. The plasticizer can lower the glass transition temperature and resulting in quicker ionic conduction. Polyurethane acrylate, the polymer matrix used in this research possess high ionic conductivity, good mechanical properties, and flexible physical properties. Polyurethane acrylate is a copolymer that has a urethane linkage and an acrylate group. It is made by mixing polyol and isocyanide by the addition of an acrylate component. For now, there are limited material for photopolymer to be used in SLA. UA is chosen because it has acrylate that allow the photopolymerization happen. The acrylate group will react to the free radicals photoinitiator and induce photopolymerization. Next, 3D structure battery, a high power density battery, usually a trade-off of lower energy density and vice versa. 3D battery architecture concept can increase the contact area of the battery component within the same footprint areas. 3D battery can be achieved by having 3D architecture of electrolytes and electrons. So in my research, I integrated the additive manufacturing into the polymer electrolyte fabrication. So why we use 3D printing is because compared to conventional battery fabrication technologies, 3D printing has several significant advantages. First, enabling the fabrication of desired complex architectures, precise controlling of the shape and thickness of the electrodes and electrolyte. The third one, printing a solid-state electrolyte with high structure and stability and safer operation. Fourth, potentially for low cost, environmental friendliness and easy of operation. Last one, possibility of eliminating the steps of device assembly and packaging via direct integration of batteries and other electronics. These are my objectives for my work. First is to develop 3D printed film PUR GPA with different weight percent of lithium perchlorate. The second objective is to investigate the effect of salt composition on the ionic conductivity via electrical impedance spectroscopy, EIS. Third one, to determine the effect of salt composition on the functional group of 3D printed GPE via Fourier transform infrared spectroscopy FIR. And the last one is to develop 3D structure of PUA GPE with different structural designs. This is my methodology. First, lithium perchlorate LiCl4 will be dissolved in dimethylbromide DMF and stirred at 1500 RPM until homogeneous. The concentration of lithium perchlorate will be ranged from 0% to 25%. Then polyurethane acrylate PUF-based resin will be added to the solution and stir again at 400 RPM for 3 hours. Then the precursor will be poured into 3D printer bed and printed into 0.5 mm films with this setting. Then after the printing process completed, the polymer chloride will be rinsed using anhydrous ethanol to wash away uncured solution. Then the sample will be characterized. This is my result and discussion. First, for the electrochemical impedance spectroscopy, the spectrum depicted the combination of real and imaginary parts of Pauli-Colle plot. The intersection points of the real z-axis was determined and used to calculate the bulk resistance of the sample. This is the intersection here. You can see 10% has the lowest bulk resistance. It means that it has the highest conductivity. The conductivity is calculated by this formula. Conductivity equals to thickness of the sample over bulk resistance times area of the sample. The highest conductivity achieved was 1.24 exponent -3 Siemens per cm at 10% lithium perchlorate, which is 4 magnitudes higher from 0%, which is 3.96 exponent -7 Siemens per cm. Beyond 10%, the conductivity decreased because of the iron phase formation. The iron phase formation will be discussed more in the FAR part. For the FAR, the addition of salt into the polymer electrolyte made the NH group shifted to a higher wave number. C double bond O become more intense and shifted to a lower wave number, and COC starts likely shifted at 15% to lower wave number. It means that these findings suggest that adding lithium salt to PUA causes multiple interaction that could change some of the polymer's microstructure. This is the FTR deconvolution. The observant peak of lithium perchlorate 650 to 600 was deconvoluted to identify the free ions and ion pairs. This is the summaries of the previous graphs. The 3D printed PUAGP at 10% lithium perchlorate possesses the highest number of free ion. The higher the free ion, the more charge carrier for the electrolyte, the higher the conductivity. The number of ion pairs increased after 10% due to the favorable formation of ion pairs instead of the formation of the free ions. As more lithium perchlorate salt was added, the free ions will dissociate and the distance between two free ions will become lesser and then combine to become ion pairs. Then the number of free ion also decreased and the conductivity also decreased. This is the 3D printed PUAGPE with different shapes. This 3D printed electrolyte shows the capability of 3D printing to fabricate 3D geometry of polymer electrolyte for 3D battery application. This is my references. For the conclusion, polyurethane acrylate gel polymer electrolyte with different concentration of lithium perchlorate were successfully printed using SLA method. The highest conductivity achieved was 1.24 power -3 Siemens per cm at 10% concentration, and the conductivity decreased beyond the optimum. There was complexion between lithium perchlorate and PUA polymer proved by the bench shift of NH, C double bond O, and COC functional group observed by FAR. Besides, the FAR deconvolution showed 10% lithium perchlorate possessed the highest amount of free ion in line with the highest ionic conductivity achieved by 3D printed PUAGPE at ambient temperature. The utilization of SLA as a method for polymer electrolyte fabrication is promising as it has a better processing process compared to the conventional method while maintaining high ionic conductivity, which is one of the most important characteristic of polymer electrolyte. That's all from me. Thank you.